Good morning, everyone. My name is Martijn Verberg. I am the Principal Software Engineering Group Manager for the Java Platform Group at Microsoft. Some of you may have known me previously from the wider Java ecosystem. I'm currently the Director at Adopt OpenJDK. I help run the London Java User Group, and I sit on a few standards bodies related to Java technology, such as the Java Community Process and the Jakarta EE, which is the new home for Java EE. Some people also know me as a diabolical developer, but I will try to behave myself as much as possible in this talk. This talk is called Modern Java for Cloud Developers, and it's aimed as a broad kind of brush journey through having a look at where Java is gone recently, where it is moving to in terms of cloud native development, and what Microsoft's investment in this space looks like and will look like going forward. If you are with us live, I have my good friend and colleague here with me, Bruno Borges. He is the Principal Program Manager for our group at Microsoft, and he'll be doing the moderation duties, so thank you, Bruno, in advance. And we both look forward to answering all of your questions as we go throughout this. So let us get started. And of course, as you would expect during a live recording, I went and hit the go forward button on the wrong screen. So we'll try that again. There we go. So this is Java at Microsoft. For those of you who have been in the industry for a while, Java and Microsoft have had a interesting history, shall we say, but certainly in the past 5 years, and absolutely true today, is that Java is incredibly welcome at Microsoft. We use it a lot internally, we actively support it now, and alongside .NET and any other runtime language you have, Azure is open to everyone. Microsoft's new strategy for being open and driving its success much through open source is a fantastic change, I think personally, and you really see that with Java coming through. This is what we'll cover today. So we're gonna just address that this is not the new normal. Then I will go into some modern Java topics, so covering some of the highlights of features that Java has added since Java 8. We are now at Java 14, would you believe? It's being released every 6 months now, so it's a big change. I'll talk about some of the changes that have been made to Java to make it more suitable for cloud workloads. In particular, its container awareness, the fact you can now package it into a much smaller size, and some internal changes that have been made to it, which allow you to run it more efficiently. I'll then cover Microsoft's investment in Java. Especially in the past year, Microsoft has certainly backed Java in a very public way through an acquisition, through signing the contributor agreement to give patches and add features to Java itself up at the OpenJDK project, so on and so forth. And then lastly, I'll cover how you can run your Java workload on Azure. Again, this will be a sort of a broad visit. There are much more detailed presentations that you can find on the Microsoft.com site. Bruno and I will give further details on that later. But in essence, no matter what type of Java workload you have, a traditional monolith sitting on a host, or an incredibly modern microservices architecture running distributed on Kubernetes, all of these workloads can be brought to Azure, and you can enjoy all of the scale, security, and intelligence that we bring with the Azure platform. As I mentioned previously, it's a little bit of metadata about this talk. I think I would like to acknowledge the new normal. You see here, Duke is following the guidance from some government institutions to wear a mask during this public talk. First of all, thank you for being here with us today. I understand, and I have this firsthand, how difficult it is to maintain both your work and life balance, to be able to connect with colleagues, to be able to have some time for self-learning. It's incredibly challenging, especially for folks who are looking after extra family members at home. I myself have a 5-year-old boy called Hunter. He may pop his head in from time to time during this recording, we shall see. And this is all part of the new normal. If you're part of the live session, we'll be doing lots of Q&A. And for those of you who are listening, I have deliberately added quite a lot of extra text to these slides. And this is purely because this presentation is going to be distributed for folks who are at home. A lot of folks will be catching up on this a little bit later on. And so it's a very different style of presentation than I would typically give to a live audience. This presentation will also be a little bit shorter than a typical live presentation. We'll see how we go. Without the live audience interaction, these things tend to go a little bit faster. For those of you who are live as such, but online, so in the chat window, etc., we will pick up your questions and give answers towards the end of the session. So please bear with us. Without further ado, we will get onto the topic of modern Java. Now, this meme has been going around for quite some time. Hopefully most of you will recognize the Monty Python sketch there about the dead parrot. Java most certainly is not dead, despite folks claiming this year after year after year, especially in the past 5 years. I will show you shortly some graphs and some statistics from the industry which most certainly prove otherwise. For a bit of a fun home exercise, Bruno has put together an excellent little quiz for you. The guess is here, how old are the top 3 languages that are currently used in the world today? The top 3 languages are JavaScript, Python, and of course Java. It'll be interesting to see if you can figure this out. So I'll give you 10 seconds or so to have a think at home. And for you, those of you on the live stream, feel free to pop in your answers, and you will get the prize of being the person who is correct if you get the closest. Okay, great. So let's have a look at these languages. Let's see how old they are. I think the dates will surprise you a little bit. Python. Python has had a massive resurgence of late. It's a very popular language, especially when it comes to data science and machine learning and statistical programming. It's 30 years old. Would you believe it? So I was myself, only 12 years old when Python first came out. And it stood the test of time, and it's obviously had a massive resurgence with Python 3, despite some difficulties transitioning from Python 2 for some folks. Again, if you're a data scientist, then it's an incredible language to use in particular. JavaScript. Most people see this as the new kid on the block, but it itself is 24 years old. That's pretty amazing, huh? JavaScript seems young because there is so much going on in that ecosystem right now, so much positive things. We have things like TypeScript, which have come out of Microsoft, which has added some really great static type safety to the JavaScript as a JavaScript wrapper. There have been new package managers, new build systems, new web frameworks. Node.js has sort of come to the fore to run JavaScript on the server side. So it's still a very vibrant, fast-moving ecosystem, and it's, again, great set of tools and languages and libraries and frameworks to use, especially for your web development. Interestingly, Java and JavaScript came about around the same time. So Java is 24 years old. It's celebrating its 25th birthday this year, which is fantastic. And like the other 2 languages, it really has stood the test of time, not in terms of just its engineering, but in terms of the community and the ecosystem it's managed to build around it. And it continues to go from strength to strength today. I won't cover all of these graphs in too much detail, but you can read this at home at your own leisure. But Java is one of the top 3 languages and consistently has been for the past, just about ever since its inception. It continues to grow more quickly in terms of popularity than any other language except for JavaScript and Python as well. So again, to sort of debunk the theory that Java is slowing down or it's becoming a new COBOL, again, it's actually accelerating in its popularity again after a short dip 5 years ago or so. Another small data point here, again, thank you Bruno for supplying this source, is that in the finance industry, it really does dominate in terms of jobs and software being built. Java continues to evolve, not only in terms of its technology, but in the way that it is now built, distributed, the freedom it now has in terms of the field of use restrictions, etc. A lot of changes have happened, especially since Java 8, and there's a lot of exciting things to explore, so I'll get into it. I'll do my best not to read from the slides directly, but to add context here as I go along the way. So some interesting highlights here is that Java is being released every 6 months, and that's a major version, not a minor version. Every 6 months you'll get, Java 13, 14, 15, 16, and so on. We've just had Java 14 released in April, and so we'll expect to see Java 15 in the September-October timeframe. Every 6 or so releases, every 3 years typically, the community has a gentle person's agreement that is a long-term service release. So for Java 11, 17, 23, 29, and so forth, all of the various vendors which produce a Java binary or an OpenJDK binary have all got a sort of a joint agreement that at OpenJDK, that source code will continue to be maintained for a very long time. So you'll continue to get security updates, performance patches, and so forth. If you're slightly more risk adverse, then I would recommend you go for the long-term service release. If you want the leading edge of exciting new developer productivity and the performance gains, then you can pretty safely jump every 6 months to the next version. A lot of people in the past have complained that Java is too large, it's too bloated, and when you deliver a Java application, it's this gigantic, high megabyte runtime that an application you have to deliver just to run Hello World. With Java 9 and the new module system, that has now changed. Instead of providing a Java runtime environment, which is the full lot of all the Java libraries and the runtime, you can now just provide the modules of Java that you need. So Java itself is being split up into various modules with a base module and then increasing layers on top of it. As an example, if you're writing a server-side application and you don't need any of the GUI libraries, you can bundle just the server modules with your code, remove all of the GUI libraries and GUI modules, and package that up using JPackage into the native format that the operating system you're aiming at needs. So JLink, the tool, will allow you to package together your modules with your application modules. And JPackage will help you turn it into a native package for the operating system, whether that be Windows, macOS, Linux. Another key point to note is that Java has moved into the container and cloud space. It is now fully container aware. I will dig into that a little bit more later. And it also has added new performance characteristics under the hood. Java famously has its own memory management system. This is part of the reason it became so popular over and above C and C++, was that engineers no longer had to worry about their pointers. So Java has these garbage collectors, but an unfortunate side effect of the garbage collectors is that under certain circumstances, the garbage collector will pause the whole JVM in order to do its cleanup. This translates as sort of application pauses or freezes, which end users can detect. And a lot of work has been done in Java to minimize the impact of that. By default, you have the G1 garbage collector, but you now also have 3 new garbage collectors coming in, which will help you either with very small microservice workloads and all the way up to gigantic big data workloads, again without having these frustrating pauses. So for small workloads, there is a new Epsilon garbage collector, which actually is a no-op. It doesn't do anything. And that is designed for microservices that you know are going to disappear quickly. So think function as a service. Your Java microservices springs up. It does some work maybe for a short amount of time, and then it disappears again. There's no need to worry about collecting garbage along the way. It's not a long-running application. For large, big data, data-intensive, compute-intensive applications or services, there are now two new garbage collectors coming in, one called ZGC, the other one called Shenandoah. They both share similar characteristics in that they can support very large heaps, 512 gig as an example. And when they run their garbage collections, when they're cleaning up memory, they're sort of doing it constantly in the background and in such a way where they do not have to pause the entire JVM. So you can imagine there's these little helper threads behind the scenes constantly just tidying up garbage along as you go, not stopping your application. It does cost a little bit of extra CPU in order to perform these operations, but that cost is fairly negligible compared to the impact that these large pauses would have. So where is modern Java being used? All over the place, but in particular Java is now dominating the big data space. So if you look at any of the popular Apache big data frameworks, such as Spark, Kafka, NiFi, Accumulo, that is all JVM or Java based. Java again is well suited with the fact it can manage memory at large scale, and its performance characteristics have always been very strong in terms of running hot code incredibly quickly and being able to deal with tens, hundreds, thousands of threads at a time. I'll cover how Microsoft uses Java later on, and you'll be surprised with how much we actually use it internally. It's really quite something. Java is free, completely free as in beer and free as in speech. The way to ensure that you get this freedom is to choose an OpenJDK distribution. OpenJDK is the open source project that makes up Java. And if you get a OpenJDK binary for one of the many vendors that supply them, it's all GPL v2, right? So it's completely free. There's no restrictions to use it. And if you want to have commercial support contracts, you can. Microsoft actually partners with Azul Systems to provide you Zulu Enterprise on Azure, which is part of any subscription that you have if you're running a Java service. So you get that support for free on Azure. For folks who are full stack developers and who are building microservices where they need to tie in some JavaScript, some React maybe, and some Java in the backend to go talk to one of the many various systems that Java supports. VS Code, that Microsoft's very popular code editor, now has Java support. It's actually really, really good. I'm starting to use it now on a daily basis myself, and it's great because it's just this lovely little lightweight editor, and you don't need to worry about all of the heavyweight features that a typical Java IDE would need. A quick shout out to educators. Java now has a REPL, so you don't need to fire up an IDE in order to teach Java to people. You can just go on the command line, just like with Python or Ruby or any of the other languages, and start teaching it. This is a duplicate slide. This is what happens when you go live. The demo gods have struck again, so I'll skip over this one. I'm now going to go into some developer productivity gains which have happened in Java recently, and I'll flick through these fairly quickly, but it's just to sort of show you that every 6 months there's continuous progress happening. The first one here was the one that was most popular. This came in Java 10, and we can now have the var type. On the left-hand side, we don't need to declare in our source code that it's of type list string or other verbose generic static typing. Due to Java's incredibly strong type inference, we can now use var on the left-hand side. It reduces the boilerplate, keeps the type safety, And here's a little tip and trick. So when I was discussing this feature with Brian Gertz, who is Oracle's Java language architect, we were discussing what the big benefit of this really was. And the benefit is that your variable names actually now come to the fore. So when you're reading your source code, you've got less boilerplate of the types, and the strength, the domain knowledge, the domain of your variable names comes through much more strongly, which means your code starts to read a little bit more like, dare I say it, plain English. We finally have text blocks in Java. Now, for folks in other language ecosystems, this has been around for quite some time. As it turns out, strings are pretty special in Java and have a lot of history, and so it took quite some clever engineering behind the scenes to actually make this work. There's a lot of deep dive detail that Bruno and I can share in terms of some links and things in the Q&A. But for folks who really need to embed that HTML in their Java strings, and please don't do this, then multi-line text blocks are finally here, which is really cool. Switch expressions. So we've had switch statements in Java for a very long time, but now we have the ability to switch on an expression instead. Another useful feature that they've added as part of this switch expression piece of work is that you can now actually have some logic within a switch case block. So you can see here in the default case, I'm actually allowed to go and do some actual business logic, dare I say it, and then yield that result back out of the switch statement. Yield is a new keyword that's come into Java for this case. Excuse the pun. And folks have just started using this, and we'll see a lot more usage as people start to get creative with the expressions. Java 14, this is the thing that everyone was waiting for. Now, it's not fully implemented behind the scenes. This isn't value types. This isn't the full end game of Project Valhalla yet. But we now have records in Java. So these are constructs which are effectively data holders without all of the overhead that a Java object typically has. This means we can start packing our 2- and 3-dimensional arrays. This means we can start doing things like data science much more efficiently inside Java. This means we can model our domain more accurately when we're talking about, for example, graphing some numbers. This is really exciting, and there's a lot more work going on under the hood to make this even more efficient. One of the incredible side benefits that will come into the next few versions of Java is that this is going to dramatically reduce the memory overhead. A lot of Java code these days is what we would call sort of Java bean code, where people are just putting in getters and setters, and their Java objects are really just data holders. Replacing them with records is going to save you a lot of memory. Finally, the dreaded null pointer exception has a much more fuller explanation. So if you have a chain of callers, and in the past, a null pointer exception, you wouldn't know which chain was the NP belonged to. But this time, you now get a much more detailed exception. This is long overdue, and I'm hoping one day still they will accept my request to call it a null reference exception. Because that is what it really is. We're talking about references here, not really pointers, which does confuse newcomers to the language. But this is a great feature nonetheless. More debugging is always welcome. Right, in this next section, and I'll take a little drink here, I'm going to talk a little bit about the improvements Java has made for it to operate in the cloud more efficiently. I'll begin with smaller Java. As I mentioned previously, Java is now fully modularized, which means you can really tightly pack the core Java modules you need to run your application with the application itself. You can bundle that even as a native package for the operating system. And it's this tiny, lovely, custom-built package that you need just for your distribution. Again, it's fully container aware now. So as of Java 8, update 191, so if you're on Java 8, please make sure you upgrade to at least that version. Java is completely aware of the container it's running in terms of the CPU that's available to it, in terms of the memory that's available to it. I've just listed there a couple of flags that you can use to fine-tune that deliberately, so you can very tightly tie how much memory your Java is using to how much memory the container is offering it. But generally speaking, if you're on a modern version of Java, you can just drop your Java into that container and it will do what is needful. Java is lighter. So again, under the hood, the engineers in particular at Oracle who work on the hotspot VM, which is what drives Java under the hood, what drives the runtime behavior. Some improvements that came in recently. Strings are deduplicated. So if you imagine you've got a application that is heavily uses JSON, XML, or other strings, and strings are effectively duplicators, the JVM can now detect that and deduplicates them, which is fantastic. So instantly, for many applications, you have a much lighter memory footprint. Applications now start faster. You've got class and application data sharing. So you have a run of your application, it saves off the metadata from the classes, etc. that was loaded. The next time around that application starts, it reads from that metadata in memory and starts the whole thing much faster. We have just ahead of time static compilation now available, and more of that technology is coming into Java every 6 months. Java has always had a very strong open source partnership. So again, no matter what type of asynchronous reactive, buzzword compliance type of streaming application or service you're building, there is a solution either built into Java or as one of the many libraries that are available. And of course, Java big strength, one of its major strengths is its backwards compatibility. So every time you upgrade Java, your code just tends to work, and out of the box it just gets faster, right? Which is fantastic. I've mentioned that it was container aware. I've mentioned about the GCs before. One exciting new thing that's coming along is lightweight fibers, or some people think of them as coroutines or lightweight threads. That's coming into Java really soon. They've almost completed they've completed all the prototypes and things, and they're just ironing out some of the last kinks. So we're going to see another massive performance boost to Java here in terms of lightweight threads, which is really exciting. To add some context there, a Java thread typically maps one-to-one to an operating system thread. And so you can imagine if you've got hundreds, if not thousands, of Java threads all contending over a resource. That's effectively forcing the operating system to contend over the resource with its heavyweight threads as well. So that's not necessary in a lot of cases, and Project Loom is going to help take that away. Next, I'd like to cover Microsoft's investment in Java. As you saw at the very beginning of the talk, we've got Duke riding the dinosaur. Microsoft loves Java, has actually loved Java for quite some time now, but is now making that investment more public. And so I'll cover some of the highlights here. We use Java a lot. I came in as part of the JClarity acquisition in August last year, and one of the things that Bruno and myself did was to survey the landscape of Java at Microsoft and to see where it was all being used. And as we discovered, Java is probably Microsoft is probably one of the biggest users of Java on the planet. LinkedIn, which is a Microsoft subsidiary, has over 1,500 Java microservices. It is the creator of Apache Kafka and several other projects. It's obviously a very heavy contributor. We have a whole host of Azure services which are Java backed. So Azure HD Insight, Databricks, Spring Cloud, and a whole host of others are there. SQL Server actually has some Java embedded in it. Who knew? I learned something that day. Yammer has its backend implemented in Java. If any of you have children, or if you are a child at heart, you've probably played Minecraft. The Java client is still incredibly popular, and behind the scenes, there's still a lot of Java being used to run the servers. And of course, there's our investment in Android as well. So we're investing in Java itself now. we've signed the OpenJDK committer agreement, and we have already submitted our first patches to OpenJDK, and we're working alongside partners such as Red Hat, Oracle, Azul, to name a few, at OpenJDK to improve Java for everyone. And that's really our ethos here. Everything that Microsoft is doing in terms of improving the Java runtime for Azure workloads, we intend to upstream as much as we can, all of it, if at all possible, if it will be accepted by OpenJDK. We are here to give to the ecosystem which has given so much to us. Microsoft is also a primary platinum sponsor of Adopt OpenJDK. This is the most popular OpenJDK distribution out there today. I mentioned previously that OpenJDK is the open source project that is effectively behind Java. That means Java can be built by multiple vendors. Oracle's JDK is the most popular, but you have a whole host of others, and Adopt OpenJDK is the most popular that wraps OpenJDK itself. And Microsoft is a solutions member of the Eclipse Foundation. Eclipse is a software foundation where a large number of forward-looking Java projects, libraries, frameworks, and ecosystems live, and Microsoft is contributing directly there. Microsoft acquired a Java company, and I'm personally very excited about this acquisition because, well, full disclaimer, I was the CEO of jClarity, so it was really strange when we first came and talked to Microsoft. Again, the long history there with Java. It wasn't a strong history. There wasn't a lot of tie-ins with Microsoft and Java over the years. But it was really refreshing to hear what their plans were, not just for Java, but for any managed runtime that would run on Azure, right? They really want Azure to be open for the world. Anything that runs in the world should be able to run on Azure, which is a fantastic goal. And with the jClarity acquisition, alongside me came Kirk Pepperdine, who's a very well-known Java performing tuning expert, John Oliver, who is a machine learning expert in Java performance analysis, George Adams is one of the new program managers here, and some other folks as well. All of this, combined with some other fantastic hires in the ecosystem, such as Monica Beckworth, who used to be Oracle's Java performance lead, means that we now have the capacity really to give back, to optimize Java for Azure, as well as to give back to the wider ecosystem. One of the things that our colleagues over in DevDiv have done is built the Azure Spring Cloud Service. So Spring is the most popular framework for building web applications in particular. Spring Cloud is a very popular subset of that. And we have a Spring Cloud service which is going GA during build, so this week, which is super exciting. It's in all the hero locations, and if you have a Spring workload today, then I highly recommend you go check it out. We're also starting to invest in our tooling around Java. So with GitHub, we have actions, packages, security advisories that all tie into the Java ecosystem. I mentioned before about Visual Studio Code now having a really strong Java plugin. Again, I use this now on a daily basis. Obviously, it is embedded inside SQL Server. And I'm sure no one's missed it, but we now have a subsystem for Linux in Windows. Full inception has been reached. So, to recap a little bit, Java has modernized, it's being released more quickly, it has a ton of new developer productivity, a whole bunch of enhancements have been made to it under the hood to make it optimized for running on cloud. Microsoft has seen that, it's investing heavily in Java, it is building services and has built services to bring your Java workloads to Azure and start running them on there. And this is what I'll cover next. Again, this is more of a broad brush than a deep dive, but I hope during this little segment that you will definitely see how much support we have for your Java workload on Azure. So I'll start. Java applications come in all shapes and sizes, don't they? Some of you will be working on a monolith. Some of you will be working on a monolith which has been containerized in Docker or Kubernetes, using a combination of Docker and Kubernetes typically. Some folks have split their monolith apart, so on and so forth. No matter what shape your Java application or service is in, we actually have a home for it here in Azure. So everything from being able to just grab a Azure VM, like an IaaS machine, so infrastructure as a service, all the way through to managed Kubernetes in our AKS platform, through to platform as a service, so things like Spring Cloud. So no matter what state your Java application is in, you can bring it to Azure, and then we can help you modernize it even further after that. So here is a example of the sorts of different migrations that are available to you. If you've just got a core Java SE app and it's currently running Tomcat, as an example, you can run app service on Linux here at Microsoft. If you're running a Spring application, we have a platform as a service for you. If you want to do a DIY, if you want to bring your Red Hat OpenShift or your Pivotal Cloud Foundry expertise to the table, you can bring that onto Azure as well. And if you want to go, slightly lower level, you either just want a straight VM or you just want, a managed Kubernetes container service, we have that for you here as well. You can bring any type of Java workload, whether it be a Spring, Java EE, Jakarta EE, microprofile, straight out Java SE application. We have support for all of it here. Here's a small highlight of the services we have for Java, and more of these are constantly being thought of and added, and you'll see public announcements usually happening every semester. At the moment, for example, we have app service, functions, Spring Cloud, a few other highlights here. We have service buses. We have monitoring through Azure Monitor, so it means that you can get things like Java's flight recorder data, the telemetry from that, and have that analyzed for you. We have big data solutions with Cosmos, so on and so forth. Azure App Service runs on Azure Compute, obviously. There's just whatever you're bringing, we have typically have a service for it. There goes functions flying in. Azure Spring Cloud is the latest offering. As I mentioned before, it's going GA during Microsoft Build. It was jointly developed with our partners Pivotal, VMware. There are 0 code changes you need to make. You just bring along your Spring app and deploy it into the Spring Cloud. We have out-of-the-box monitoring and tracing. You can use either our Azure Monitor and App Insights, or if you're already an existing New Relic or Dynatrace customer, for example, or App Dynamics, that's where you can tie that in immediately as well. And you can use Pivotal's managed service. Again, this is going GA in all the hero locations. If you are a Spring developer today, or if you're maintaining a Spring system, and you'd like to have all of the heavy lifting done for you by cloud, then I highly recommend you try Azure out. The Java or the OpenJDK that we supply on Azure today is from Azul System, who have been a fantastic partner for us. They bring their OpenJDK called Zulu, in particular Zulu Enterprise. We have that supported on Linux, Mac, and Windows on Azure. And basically, it's available for all of our environments. It provides you the sort of commercial support you would expect for having support behind a Java runtime. And so should the unlikely occurrence of a JVM performance issue or crash occur, you've got Microsoft backing you, and you've got Azure backing that as well. And we look forward to continuing that partnership. There's more. Azure SDK. So there is a Java client for touching just about every aspect of Azure today. We have a fantastic team headed by Jonathan Giles, who's all the way down in New Zealand actually. We have a series of build plugins, obviously Azure DevOps and GitHub support all of the CI/CD that you'd need for Java. Again, we have the very popular Apache Kafka API support for event streaming. We have also support for the very popular Java messaging support in preview mode. So to reiterate, whether you're bringing sort of, dare I say it, a legacy monolithic application with a whole bunch of connectors to interesting but very valuable technologies, you can come and bring that to Azure. If you have something more container Kubernetes based, we have managed containers for you, or you can run it yourself on a VM so you wish. And if you just want to deploy to a platform, we have Azure Spring Cloud in particular. So we're going to come to the end of the talk now. In conclusion, I'd just like to wrap up with a few points, just for you to take away. Java's core proposition has been modernized. We are now on to Java 14. There's a whole host of new developer productivity, which is fantastic for the day-to-day Java engineer. For folks who run Java and who run Java at scale, there has also been a ton of performance enhancements added to the JVM itself, which means you just get faster, more stable applications out of the box. For folks who have modernized their application to containers, Java now supports this 100%. It completely understands the CPU that it's being given, the memory that it's being given, and you can package your Java application much smaller so that your containers are as little as possible, because we all know we want to keep those containers nice and small and resource efficient. Microsoft is investing heavily in Java and continues to do so, and will continue to do so. We have my group, the Java Platform Group, which is contributing directly to OpenJDK, which is also directly contributing performance analysis tooling. We also have other groups inside Microsoft who are pushing all of the big data services that we have through the Apache projects I mentioned previously, who are putting up services such as Azure Spring Cloud, and who are building client SDKs to talk to Azure services. And last, and absolutely certainly not least, you can bring any Java workload to Azure. It is a fantastic cloud. It will give you the scalability you want, the reliability you want, the monitoring, all of the good stuff that cloud provides you, with a whole host of solutions for you to bring your Java workload over, whether that be a monolith on a VM all the way through to something like a platform as a service with Azure Spring Cloud. So with that, I will wrap up. Thank you very much for your attention, especially during these challenging times. My name was Martijn Verburg. Again, I'm the Principal Software Engineering Group Manager at Microsoft. With me moderating is Bruno, and please add your Q&A if you are with us live, and we will get to answering them.